So in this question, we'll be doing with the question under interference of sound. So this is a question which you can find in CWay Physics, College Physics, 11th edition. It's under problems, after you are done with the topic of sound. So to start, the question reads: two cars are stuck in a traffic jam and each sounds its horn at a frequency of 625 Hz. A bicyclist between the two cars 4.5 meters from each horn, as shown in the figure P14.37, is disturbed to find she is at a point of constructive interference. So how far backwards must she move to reach the nearest point of destructive interference? Okay, so we continue. So this is the diagram. So this is a motor vehicle. So the bicyclist is here. Then this bicyclist, the distance between here, it's 4.5 meters, which is this 4.5 meters. And also the distance here to here, where there's a horn, it's 4.5 meters. So they are asking if at this point where this bicyclist is experiencing a constructive interference, meaning there is maximum sound produced. So they are asking us, by how far should this bicyclist move backwards so that she experiences the nearest point of a destructive interference. So she needs to move backwards so that she can experience the nearest point of destructive interference. So this is how we are supposed to understand the question. So in physics, it's very important that you come up with the simplest possible diagram. We call it free body diagram, so that you are able to understand. And if you are able to draw a free body diagram, that shows that you have understood the question. So this is our free body diagram. So this is the bicyclist. Then we assume this is where the vehicle is, also here. So we assume that this is the bicyclist here. So this bicyclist needs to move this side. So if the distance between here and here is 4.5, then also here and here is 4.5. So for this person, when this person moves backwards, meaning we'll have 4.5, meaning this distance here will subtract with the distance he has moved, which we don't know. So we'll say that distance, which we don't know, it's x. So it will be 4.5 minus x. This is where the 4.5 is coming from. So since he has moved this side, it means since he has moved to the left, it means that the distance here, it will be increased, meaning there will be a distance which we don't know. So we'll say plus x. So this is where this plus x is coming from. So 4.5 plus x, this is the distance there. So we continue. So now, since we've understood the question in this form, we can now come up with this equation. This is the equation for destructive interference. So it's R2 minus R1 is equal to lambda over 2. Lambda represents the wavelength. So we'll say R2 will get the longest possible distance. So the longest possible distance here is 4.5 plus x, which is this one here. Then the shortest possible distance, we'll subtract it, which is 4.5 minus x, which is this one. So then this lambda represents the wavelength. So now we need to find the wavelength. So the formula for wavelength is this one given here, which is v representing velocity is equal to lambda multiplied by the frequency. So we've been given the speed, or if it's not given, we usually consider the speed 343, which is I'm sure it's a speed speed of sound in air at 20 degrees Celsius. This is the speed we use. Then the lambda is the one we're trying to calculate. So the frequency in the question they've given us to be 625. So we can confirm if indeed it's 625. We can go back to the question. Yes, in the question they've said the frequency it's 625 Hz, which is here. Okay, so so we continue. So when you divide 343 by 625, you find that the lambda is 0.55 meters. So since we are dealing with physics, we are supposed to put this in scientific notation. So yes, I mean we are supposed to put the units. We should use the SI units. Yes, sorry for that mistake. So we can't convert this to centimeters or millimeters. So we just have to make sure that the lambda is in meters. So this is the lambda. So now we will continue this minus that. So when you multiply a minus multiplied by that, it will give us this minus negative 4.5. Negative multiplied by this negative, it will give us a positive here. Then the lambda will replace it by this lambda 0.55, which we've calculated from here. So we'll say 4.5 plus x plus this x. So we'll collect the like terms. Then negative 4.5 is equal to, when you divide that, it will give us 0.2744. So now here we'll collect so at this point we'll collect the like terms together. So this negative 4.5 and negative 4.5 plus this 4.5, they will simplify, so they will give us a 0. Then this x and x, they will add, so it will give us 2x. Then here when we divided, we got this. So now we have to divide by 2, so that we divide by 2 both sides, so that we remain with the value of x. We find the value of x. So 0.274 divided by 2 gives us x is equal to 0.1372. So this is the this is the answer. So this is the distance supposed to move backwards so that this bicyclist can experience a destructive interference. So thank you for watching the video. Remember to subscribe to our YouTube channels.